10 centimeter. Will I make a 10 centimeter map and give it to you?
No.
No.
I can blow it up. How much time I can blow? 4 times.
4 times.
So 250,000 4 times if I blow, what will be the scale?
1000.
1 is to 600, 6,000.
Yeah, 660. 1 is to 60,000. See, blowing means scale will become less. Correct? No?
Yeah.
250 kilometer, 250 kilometer is 1 meter here. Now, when you blow it,
600
you make 1000 in 1
kilometers.
meter or you make 60 in 1 meter, approximately 60. But do you want to make a 1 is to 60,000 scale? That's not a good number. So what do? 1 is to 50,000 scale.
Okay.
That's why you have got this map example. I just saw this, that's why I explained all this. 1 is to 50,000 scale map. Got this? So 1 is to 50,000 scale map is this.
Okay.
So when I say 1 is to 50,000 scale map, definitely I will know. What do I know? This is a piece taken from 1 is to, it is not a total. See, that's why they showed 70 to 40 degree and 24 35 degree. Correct? 70 to 40 degree. 24 35 degree. Got it?
Yeah.
70 to 40 degree. So this is some portion. What will be the total one? They will never give you a free map like this. Full one. Okay. Now this map would have been very big. This size. 1 is to 50,000 scale. So now you compute the same way. 1 is to 50,000 scale. You are printing a map, and this is 1 is to 50,000 scale. What is the map number? 56H by 8 say. This represents approximately 25 kilometer. So what will be the size of the map?
Which represents 25. Which represents 25.
25 kilometer.
Whole
1 is to 50,000 is the map scale.
Okay.
25 kilometer you have to print. In what scale you can print it?
Achha.
And how much is the width? Earlier you have computed 40 centimeter.
Sir, I didn't understand the part of 1 is to 60.
No, we are not printing 1 is to 60. We are printing it 1 is to 50,000 scale. Because that's a standard number. Okay. I have a map now. 1 is to 50,000 scale.
Okay.
It represents 25 kilometers. If I have to, what are you doing? Whatever is there, assume that in the center of the earth you have got a light kept.
Okay.
And whatever equator, boundary of the country, everything you have put on lines.
Okay.
And it is a transparent media. So when the light reflects
On the paper only the.
on the paper, you will see whatever is there, right? Suppose it is touching at the equator. Exactly the projection will be 90 degree.
Okay.
But whatever is here, it will have a distorted projection. The actual quantity on the globe will be less, but here it will be seen elongated.
Okay.
The scale will become correct here,
Okay.
but the scale will
On the
vary
plane
as it goes.
projection.
And
Yeah.
on the pole, what will happen? Nothing will get projected because it's cylinder.
Yeah. Yeah.
So this cylindrical projection is good for maps which are closer to equator.
Okay.
Far from equator,
They distorted.
they distort it and sometimes you cannot make the map. But nobody says you can keep cylinder like this only. If my aim is to map the
Top portion.
top, I will put a cylinder like this.
Okay.
So this is called orthogonal cylinder.
Okay.
This is called a normal cylinder.
Okay.
If I want my country is somewhere here, I'll put a cylinder like this. Tilted cylinder. Still I can use the cylinder. But my problem is like a country like India, we have 4 degree to 40 degree. Okay. So you can, 4 degree is good. At 4 degree you can keep a cylinder. But 40 degree gets large distortion.
Cone.
Therefore what they have decided, I put a cone.
Conical.
You don't have this distortion problem. You put a cone like this. And then start. And it automatically the scale is good. But then my problem again will be at the equator it touches. 4 degree will be slightly distorted.